All right, welcome to a class on indices. So in this topic, we'll be talking about indices, which is a very important tool in algebra. So you see, algebra is a branch of mathematics which is very important. It deals with working with unknowns, with solving equations, solving expressions. Writing algebraic expressions, simplifying, expanding, and all that. But the point of this video is to start with the algebra of powers. In mathematics, we call those powers indices, right? The power of a number, like say 3 to the power of 5 and so on. So that's what the interest of this topic is, indices. So in order to really appreciate indices, we need to, or to understand indices for that matter, we need to start with a bunch of rules, right? So we need to have rules of indices to work with. So what do I mean by rules of indices? So let me start with that. So we have the rules to follow, some rules. So let's start with the simplest rule. And how does it work? Say we have a number, x to the power of a multiplied by another number, but ensuring that it is the same number type. So like x to the power of b. Now, given that your x and your x, like this, the exact same number, right? And they're multiplying them, we can actually just add up the powers in this format and say this is x to the power of a plus b, right? So we are adding the powers, x raised to the power of a times x raised to the power of b equals x raised to the power of a plus b. So let's see where this works out. Say for example, so my intention is just to try and explain the concept, just so we get it for some of them anyway. So let's say we have 2 raised to the power of 3 multiplied by 2 raised to the power of 4. According to this rule, we will say 2 raised to the power of 3 plus 4, and that is 2 to the power of 7. So if we have 2 raised to the power of 3 multiplied by 2 to the power of 4, we add up the powers, which is 3 and 4, and that gives us 2 to the power of 7. So that's the basic idea. And are we sure this works? Let's test it out. Is this something that makes sense in mathematics? Let me show you that it does. So recall that 2 to the power of 3 and 2 to the power of 4 are the problems we are working with. But your 2 raised to the power of 3 is the same as 2 times 2 times 2, and 2 to the power of 4 is 2 times 2 times 2 times 2. That's saying you can write 2 to the power of 3 as 2 in 3 places, and 2 to the power of 4 as 2 in 4 places. So if we add these two together, you have a result that says 2 times 2 times 2, which is the first one, times, what do we have for the second one? 2 times 2 times 2 times 2, which we can summarize as 1, 2, 3, 4, 5, 6, 7. So that's 2 to the power of 7. Okay, so now what this rule doesn't cover is that saying that this 2 to the power of 3, and that's if this number and this number are not the same. If they are not the same, then you can't add up the powers. You do something different entirely. Okay, so the second rule of indices is very similar to the first one, and that is something like x to the power of a divided by x to the power of b. So if addition means that you add the powers, your division will mean you subtract the powers. So that's x to the power of a minus b. So in the case of what we have here, we'll have 2 to the power of 3 divided by 2 to the power of 4. We will say 3 minus 4, which gives us 2 to the power of minus 1. Okay, so that is basically how that works. So let's take the third rule. Let's say we have x to the power of 0. Now, in mathematics, when you express anything to the power of 0, we decided that it is 1. Anything raised to the power of 0 will give you 1. So 50 raised to the power of 0 is 1. Y raised to the power of 0 is 1, and so on, like that. So the next one is, say you have a relationship between brackets, like a function of a function. Say, for example, let's say we have x to the power of a. Now it is now raised to the power of b, for example. So in mathematics, we say this is x raised to the power of a times b. That's the inner power and the outer power will multiply. And we can say that is x raised to the power of a b. So let's see where that really works together. So let's say, for example, we have this. Let's say we have 3 raised to the power of 2 or raised to the power of 3, for example. Okay, so what does this mean in normal mathematics, without taking advantage of the rule given to us by the indices rules? We would have said 3 raised to the power of 2 or to the power of 3 is multiplying 3 raised to the power of 2 in 3 different places. That's like saying 3 raised to the power of 2 times 3 to the power of 2 times 3 to the power of 2. Now, from what we just knew from rule 1, by applying rule 1, we could say this is 3 to the power of 2 plus 2 plus 2. And that's because all these numbers are adding each other, are multiplying each other, and they are all 3. They are all the same number. So we have that to give us 3 to the power of 6. Now, if we apply the rule of indices 4, that's x to the power of a all to the power of b, all you just have to do is multiply the inner power and the outer power. And that is like saying 3 raised to the power of 2 times 3, which gives us 3 raised to the power of 6. And also, if you missed this, in case you didn't catch it, in algebra, when we have two numbers multiply themselves, two variables, or two unknowns multiply themselves, we can simply write them together like this. So your a times b means ab. Similarly, your x times y means xy. Okay, so your rule number 5 is that when you take anything next to the power of a negative number, right? So x raised to the power of minus n, for example, is going to be, now the negative power means we say 1 over, then you write the remaining powers, which is x to the power of n. So that's how that works, right? If your negative power means we say x raised to the power of minus n, we have 1 over x to the power of n. So that's how that works basically. So since we've reached the 5, let's check it out from the beginning again before we move further. So x to the power of a times x to the power of b, because the same number multiplies itself but raised to the power different powers, we can add them up. Even if it's raised to the same power, like in the case of this, we still add it all up. But again, be careful, we don't use them if they have different numbers. We don't apply the rule. So in the case if it is a division and not a multiplication, you subtract in the order you see it. Okay, anything raised to the power of 0 will give you 1. Now you have an inner and outer bracket situation like this. You just simply multiply the inner and the outer brackets. Now number 5, we have anything raised to the power of a negative number. Negative number means we do a 1 over x to the power of n. So the next rule we'll look at is having to do with a fractional power. So what if you have a fractional power like this? Now let's say we have x raised to the power of 1 over n, for example. Now it's going to give us the nth root of x all to the power of 1. So that means the number in the denominator, you are going to root it. That's going to be your root, right? So that's going to basically be your roots, but the power on top is going to be all to the power of that number. So, but we know anything raised to the power of 1 will give you that thing in essence. So that's going to give us the nth root of x. So what if we have something else going on there? What if we have x raised to the power of m over n? So it's still going to basically be the same thing. You'll follow the same idea. Your nth roots, that's this denominator of x, now all to the power of m. So that's it. So those are the rules of algebra that we have. So let's try and maybe present this in an example format. So let's say we have 81 raised to the power of 3 over 4. So that's like saying the fourth root, the quad root of 81, but all to the power of 3. So we know 3 in 4 places makes 81. And that's like saying 3 times 3 times 3 times 3. So 3 times 3 is a 9. 9 times 3 is 27. 27 times 3 is 81. So the fourth root or the quad root of 81 will give us 3. And that is like 3. So all of this here in the bracket says 3. But now it is raised to the power of 3. That's 3 raised to the power of 3, which makes it 27. So that's the answer to that. So those are the rules of indices, and those are the rules that will guide us in future examples and classes, right? So in case you do not understand, it's better if you watch the video from the beginning again so that you catch those things you did not. But in any case, those are the rules of indices, and let's catch up in the next video.